Good evening everyone, good evening. Welcome back to JEE Enthuse. I hope you guys are doing great, having a good time. Well people, let me know in the chat box if I'm audible and visible to everyone. Just give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to everyone or not. Hello Adnan, hi Netra, hello Subhashri, hi Clay. Hello Neela, hi Manisha, hello Sahana, Abhi, Ashwarya. Let me know in the chat box, give me some thumbs ups in the chat box, give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not. Yeah? Perfect guys, perfect. So, as you all must be knowing, tonight we are going to do one more mock test of your complete chemistry for JEE 2021, yeah? So before starting the session, for the ones who do not know me, let me introduce myself. My name is Wassim and I'm your chemistry master teacher writer on this JEE Enthuse channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends and do not forget to subscribe to the channel as well, yeah? And do not forget to hit the bell icon so that you get the notification of every single session which we will be taking live on this JEE Enthuse channel. Yes? Perfect guys. So you can let me know in the chat box if you guys are super duper excited about the mock test, right? Let me know in the chat box if you guys are super duper excited about the mock test, right? That's great, Kirthi, that's great. Just let me know in the chat box if you guys are super duper excited about the session. Ashwarya, sir, how can I join in your batch? Ashwarya, there is a link in the description box of the video. You need to click on the link and you need to use my coupon code, which is WSPRO, right? Perfect, guys. Perfect. Anurag, Menti, I'll be taking some other day, not tonight. Oh, VSG is here after so long, yeah? Welcome. Perfect guys, so let's get started, let's get going with the tonight's mock test, right? I have come up with a set of questions and I'm sure by solving these questions, you'll get the idea of your preparation level at, yes? Perfect, so let's get going, let's get started with the first question which is on your screen, right? The question was asked in JEE Mains 2020, 7th Jan attempt. You guys are going to give it a try. A very simple question was asked from the atomic structure in Mains 2020 7th Jan attempt, right? Let me know in the chat box what do you think should be the answer. The number of orbitals associated with quantum number n is equal to 5. ms spin quantum number is plus 1/2. What do you think about this question? Yes, Nitish, you can watch it, absolutely. What do you think about it? The number of orbitals associated with the quantum number n is equal to 5 and s is equal to plus 1/2. What do you think about this question? Let me know fast. Well, people, majority of the people are saying option A, which is absolutely correct option, right? Why is it? See, first of all, the quantum number which I'm given with, that's n is equal to 5, right? N is equal to 5, right? And at the same time, I'm given with the spin, which is equal to plus 1/2, correct? Let me tell you, this spin has got nothing to do with the number of orbitals. Right? This spin quantum number, it simply gives you the idea of whether the electron will be going with clockwise spin or is it going with the anti-clockwise spin. So this spin quantum number, it has got nothing to do with the number of orbitals, right? Well people, there's a simple formula to calculate the number of orbitals in a particular shell. Well, let me tell you, the maximum number of orbitals in a particular shell is always equal to n square, right? Where n is the principal quantum number. Well, the n value was given as 5, so 5 ka square comes out to be 25. So there will be total 25 orbitals in the shell number 5 exactly, okay? So this spin over here, which was given as plus 1/2, this was just to confuse you. Let me tell you, the spin quantum number, it has got nothing to do with the number of orbitals, right? The spin quantum number, it simply gives you the idea of whether the electron in the orbital is going with clockwise spin or anti-clockwise spin. As simple as that, right? So correct option is supposed to be option 1, and I'm sure all of you have done it properly. Okay? Well, let's move on to one more question then. Let's move on to one more question. The third ionization enthalpy is minimum for. The question was asked in Mains 2020, 8th January attempt. Okay? Author, you'll be getting the PDF of the tonight's session in the Telegram link. Okay? I mean in the Telegram group. If you have not joined into the Telegram group, do join in. There's a link in the description box of the video. You need to click on that link. You'll be automatically getting added into the Telegram group. There you'll be getting the PDF of the session. It's okay, Purab, it's okay. Well, let me know the answer of this question. Again, it's very simple, yeah? The third ionization enthalpy is minimum for. The third ionization enthalpy is minimum for. Give it a try. Let me know the answer in the chat box. Let me know the answer in the chat box. It's a very simple question provided you know the outermost configuration of these elements, right? First of all, if you talk about manganese, manganese has got the configuration of, okay, first of all, without talking about the configuration, let me tell you one important thing first of all. See, as per the question, we are supposed to check the third ionization enthalpy, right? Third ionization enthalpy. What does that mean? That means 2 electrons are already out from this element. Now I'm going to take the third electron out, right? The amount of energy which is needed to take the third electron out from this Mn is what I call as the third ionization energy of this manganese. Similarly, I can say the amount of energy which is needed to take out the third electron from this cobalt, that's what I call as third ionization energy of this cobalt. Similarly, the amount of energy which is needed to knock out, to remove the third electron from this iron, that's something which I call as the third ionization energy of iron. So basically what we are doing over here is, right here Mn is already in dye positive state, cobalt is already in dye positive state, everyone over here is in dye positive state, right? Now, third ionization energy simply means the amount of energy which is needed to take the outermost electron out from this Mn dye positive. That's what I'll be calling as third ionization energy of Mn dye positive. Similarly, the amount of energy which is needed to take the outermost electron out from this CO dye positive will be its third ionization energy. Similarly, the amount of energy needed to take the outermost electron out from this Fe dye positive is something which I call as third ionization energy of this iron. Okay. Now, first of all, you should know the electronic configuration of these elements over here. Understand. See, if you talk about the outermost configuration of manganese, it's 3d5 4s2, right? Iron, its outermost configuration is 3d6 4s2, cobalt 3d7 4s2, nickel 3d8 4s2. But right here, we are talking about the third ionization energy. That means I'm going to write the element in dye positive state, okay? So basically, we have to take the electron out from this configuration, okay, in case of manganese. Similarly, we have to take the electron out from this configuration, and this configuration. Now, where the amount of energy needed to take the third electron out will be less among all. Just check the configurations. Just check the configuration. Over here, you have got 3d5 configuration. So to take the electron out from 3d5 configuration, you need a lot of energy because 3d5 is exactly half-filled configuration, right? Which is very, very stable, right? Now among these three, these three. Over here, we have got 3d6. Over here, we have got 3d7. Over here, we have got 3d8 configuration. Okay. Now, which one will have the least ionization energy among these, right? Where will be the amount of energy needed less in order to take the outermost electron out from these configurations? See guys, the atomic number of iron is 26, this is 27, this is 28, correct? Yes, right? So people, if I ask you, where is the effective nuclear charge less among the two? So basically we can say there are 26 protons in iron, 27 protons in cobalt, 28 protons in nickel. So iron has got minimum number of protons among these three, right? If iron has got minimum number of protons among these three, so I'll say iron will have less effective nuclear charge among these three. If iron has got the less effective nuclear charge among these three, so I'll say amount of energy needed to knock out the outermost electron from this configuration will be absolutely the least among the all, right? So iron is going to be the one which will show minimum third ionization energy among the following, yeah? As simple as that. I'm sure it's clear to everyone, yeah? The question was asked in your mains 2020 8th Jan attempt, right? Perfect, guys, perfect. So based on the effective nuclear charge, you'll be deciding the third ionization energy over here, correct? Wonderful. Let's move on to one more question. The question was asked in JEE Mains 2021, 25th Feb, yeah? Okay, that means this year question it is. See what kind of simple question was asked from the chapter States of Matter. A car tire is filled with nitrogen gas at 35 psi at 27 degrees centigrade. It will burst if pressure exceeds 40 psi, the temperature in degrees centigrade at which the car tire will burst. Okay, well, we will have a look. Understand properly what is given to me and what am I supposed to calculate. The initial pressure of the tire, which I'm representing by P1, that's given to me as 35 psi, right? Where psi is the unit of pressure right now. The initial temperature, when the pressure of the nitrogen gas inside the tire was 35 psi, at that time temperature was 27 degrees centigrade, which means 300 Kelvin, correct? Okay. Well, people, the final pressure is given to me as 40 psi, correct? What am I supposed to calculate? I'm supposed to calculate the final temperature, that too in degrees centigrade. As simple as that, right? Okay. So which kind of equation I'll be using over here? So I'll be using the Gay-Lussac's law. I'll be using the Gay-Lussac's law, in which number of moles of gas and volume of the gas is kept constant, right? So as per Gay-Lussac's law is concerned, I can say P1 divided by P2 is equal to T1 divided by T2. P1 value is given to me as 35, P2 value is given to me as 40 is equal to T1 value is given to me as 300, and from here I'll be getting the T2 value, and whatever will be the T2 value coming out to be from here, that is going to be in Kelvin. And once I get the final temperature in Kelvin, I'll simply convert that into degrees centigrade. As simple as that, yeah? This is the procedure which I'll be doing in order to solve this question, right? So T2 value you are getting exactly as 342.86 Kelvin, which is exactly going to be 69.85 degrees centigrade, right? Okay, let me know in the chat box if it's clear to every single guy. Paritosh, I'll be letting you know about that once I join the long-term batch for JEE, okay? Well, let me know in the chat box if it's clear to everyone so that I can move on to the next one, yeah? Perfecto, wonderful. See guys, you can clearly get the idea of what kind of questions are nowadays asked in mains examination, right? The level is too down nowadays, right? It's proper like a NEET question over here, okay? And nowadays you get these sort of questions only in your mains examination, right? So be NCERT oriented nowadays for your mains examination. Perfect. The correct increasing order of the atomic radius is... The correct increasing order of the atomic radius is among the following. The question was again asked in mains 2020 8th Jan attempt, right? A very simple question. You can clearly solve this one, right? Let me know fast in the chat box. What do you think about it? Let me know fast. Let me know fast. Let me know fast. It's a very simple one. Have a look. First of all, what all elements am I given with? I'm given with fluorine, oxygen, carbon, chlorine, bromine, right? Okay, well people, this carbon, this oxygen and this fluorine, they belong to same period, right? First carbon, then nitrogen, then oxygen, then fluorine, right? They belong to the same period, right? This chlorine and bromine, chlorine I'll be writing over here after fluorine, then I'll be writing bromine over here, correct? As we move along the period, what happens to the radius? What happens to the atomic radius? Basically, as we move along the period, generally the size decreases. Generally the size decreases because effective nuclear charge increases, right? Size decreases along the period, right? And when we move from top to bottom, size decreases. Sorry, size increases, okay? When we move down the group, what happens to the size? Size increases. Now you can clearly let me know the order of the atomic size of these elements over here. I'll clearly say fluorine is going to have least size, right? Fluorine is going to have least size, correct? Fluorine will be having the least size, right? Then comes your what? Then comes your oxygen, right? Then comes your carbon. Then comes your carbon because nitrogen is not there in the list, right? And then comes your what? Then comes your chlorine, and at the end comes your, wait, I just changed the sign just a second. So after carbon, what comes? After carbon, chlorine comes, and after chlorine, we have got bromine. This is going to be the decreasing order of the size of these elements, and the question was asked in your mains 2020 8th Jan attempt, right? A very, very simple question it was. Tejaswini, the next session on atomic structure will be taken on Tuesday because Monday I'm doing a mock test. Yeah? Let me know if it's clear to everyone. Let me know if it's clear to everyone, right? So the correct answer of this question is absolutely going to be option number 1. Okay, as simple as that, right? Exactly. Wonderful, guys. Let's move on to one more question then. Okay. Arrange the following labeled hydrogens in the decreasing order of the acidity, okay? Basically, these are the hydrogens which are given to me, right? I need to check the acidity of these hydrogens. I need to check which hydrogen is more acidic. Which hydrogen is more acidic? That's something which I need to check, okay? How do I check that? How do I check that? Understand. First of all, you have got hydrogen here, hydrogen here, hydrogen here, hydrogen here, right? So first of all, take this H positive out. There will be negative charge on this oxygen. Take this H positive out, there'll be negative charge on this oxygen. Take this H positive out, there'll be negative charge on this oxygen, right? Take this H positive out, there will be negative charge on this carbon, right? Now, after taking the H positive out, you need to check the stability of negative charge over here, right? Wherever negative charge is going to be more stable, there only the H positive that you have removed, that's going to be the maximum acidic, right? Wherever the stability of negative charge will be maximum, there only I must say the H positive which you have removed, that's going to be highly acidic, right? Okay, so basically more the stability of the conjugate base, more is going to be the acidic character, which is something which you already must be knowing, yeah? Okay, so we will have a look. Now, if I ask you, where is the stability of negative charge maximum? Where is the stability of negative charge maximum? Let me first of all make the structure again over here. So you have got something like this. You have got a double bond at this position, then at this position, then at this position, and on the top you have got NO2. So over here you got something as O negative. After the removal of H positive, you got something as O negative right here. And over here, again you got O negative, correct? Right, after the removal of H positive. Then you have got one more ring attached like this. Then you have got one more ring attached like this. At the top you have got C triple bond C, and over here you have got a negative charge, and this is CO negative, that means C double bond O, O negative. Over here you have got this one, right? After taking the H positives out, you got the negative charge over here on oxygen, negative charge on this oxygen, negative charge on this oxygen, negative charge on this carbon, right? Now you need to check the stability of these negative charges, right? Well, people, as you all must be knowing, I taught you in your basic GOC as well. If you remember, I've told you negative charge carrying capacity of oxygen is far greater than the carbon. Negative charge carrying capacity of oxygen is far greater than carbon, right? Remember, first of all, negative charge on an electronegative element is considered as stable, okay? Negative charge on electronegative element is considered as stable, okay? And remember, negative charge carrying capacity of oxygen is far greater than the negative charge carrying capacity of of carbon, right? So first of all, over here we have got negative charge on oxygen, right here on oxygen, right here on oxygen, right here on carbon, right? Since oxygen has got more negative charge carrying capacity, right? So stability of negative charge on oxygen will be absolutely more than that of carbon. Yes, so the hydrogen which will be attached right here with this carbon, that is going to be least acidic, which is basically your A. So A hydrogen is going to be least acidic. A hydrogen is going to be least acidic, right? So over here you can see A hydrogen is least acidic. Over here A hydrogen is least acidic. So the answer is going to be either 1 or 3rd. Answer is going to be either 1 or 3rd, right? So these two are eliminated over here, correct? Now people understand. First of all, this negative charge is in conjugation with this pi bond, right? This negative charge is in conjugation with this pi bond, correct? So basically, this negative charge is there on 2 oxygen atoms, right? Due to resonance, negative charge is there on 2 oxygen atoms, correct? Negative charge over here is only on one oxygen atom. Negative charge over here is on only one oxygen atom, right? And in this case, negative charge is there on two oxygen atoms due to resonance. So over here, the hydrogen which is attached at this position, which means at B position, this hydrogen is going to be maximum acidic because the negative charge is more stable over here, right? Because negative charge is being dispersed at two oxygen atoms due to your what? Due to your resonance, correct? Absolutely. So the hydrogen which is attached at B position is going to be maximum acidic, right? So this is the maximum acidic hydrogen. So absolutely you got the correct option as first one. Now, since you got the answer is absolutely going to be 1. But what about these two? What about these two? What about these two? See guys, in the second ring, I mean this ring which you have, this benzene ring, and on the top of it you have got NO2, right? Can I say this is the para position with respect to NO2 and this is the meta position with respect to NO2, right? People, if you remember, at para position, this NO2, it operates minus M effect, right? It operates minus M effect. And at meta position, this NO2, it does not operate minus M effect. It simply operates minus I effect. And we know minus M dominates over minus I. We know minus M dominates over minus I, right? Okay, right? So I can clearly say this negative charge would be compensated more on this para position. Wherever negative charge gets compensated the maximum, there only stability will be more, right? Yes. So you can clearly say this negative charge over here on this oxygen is more stable than that of this negative charge. So the hydrogen which is attached at this position is going to be more acidic than that of this hydrogen, right? Okay. So C hydrogen is going to be more acidic than that of D hydrogen, okay? So absolutely C hydrogen is going to be more acidic than that of D hydrogen. So option 1 is the one which is correct among all. You can let me know in the chat box if everything is clear till here, yeah? Hello Faizur Rahman. Well Purab, I didn't see the Instagram. I mean, I didn't basically see your message, yeah? Thank you, Art and Craft by Nikhil. Hello Ronak Ashraf, how are you? Wonderful. Let's move on and let's talk about one more question. See guys, a very simple question. The question was asked in Mains 2020, right? A very simple, basic and ordinary question. I'm sure you guys are going to kill it, yeah? Yes, as simple as that. See guys, as per this question is concerned, what do we have right here? The mass of ammonia in grams produced when 2.8 kilograms of dinitrogen. So basically we have got dinitrogen, right? It's reacting with what? It's reacting with 1 kg of dihydrogen, right? And we know when N2 gas reacts with H2 gas, it leads to the formation of NH3 gas. So my first step over here is going to be the balancing of the reaction. Now the reaction is balanced, right? I'll balance the reaction. The stoichiometric coefficients are 1, 3 and 2 respectively, yeah? Okay. So at time t is equal to 0, when the reaction has not started, I'm writing at time t is equal to 0, when the reaction has not started, what is the mass of N2 that is given to me? I'm given with 2.8 kilograms of dinitrogen. 2.8 kilograms of dinitrogen. So basically, I'm given with 2,800 grams of N2 in the beginning, right? Okay. And at the same time, I'm given with 1 kg of dihydrogen as well. I've got some 1,000 grams of hydrogen with me as well at time t is equal to 0 when the reaction has not started, right? Okay. Now, first of all, I'm given with the mass of both these reactants over here. And I have told you in mole concept, whenever you'll be given with the amounts of all the reactants, at that time, we use the concept of limiting reagent, yeah? Now, people, first of all, I'll be calculating the number of moles of N2 which are given to me. Number of moles of N2 is equal to mass of N2 divided by molar mass of N2 is 28. The value comes out to be exactly 100. So basically, I'm given with 100 moles of N2. At time t is equal to 0, I've got some 100 moles of N2. And how many moles of H2 do I have? Number of moles of H2 is going to be equal to mass of H2 divided by molar mass of H2. The value comes out to be 500. So at time t is equal to 0, I've got some 500 moles of H2 as well. So if I ask you, at time t is equal to 0, how many moles of NH3 do I have? I've got 0 moles of NH3 because the reaction has not started yet, right? Now we will understand. Since I got the moles of both the reactants, now it's the time to identify the limiting reagent, yeah? So how do we identify the limiting reagent? Just divided the just divide the given moles of reactants by their respective stoichiometry coefficient, right? Which value is lesser? I'll say this value is lesser, right? The reactant which will be having lesser value of it, okay, will be your limiting reagent. So you got to know your N2 is the limiting reagent, right? Since you got to know your N2 is the limiting reagent, that means N2 will get completely consumed, right? And when N2 gets completely consumed, you'll be having 0 moles of N2 in the container. Now, your entire product is decided by the limiting reagent. We know it already, right? Entire product is decided by the limiting reagent. Okay, now it's time to use the stoichiometry. Since 1 mole of N2 gives 2 moles of NH3, so 100 moles of N2 should give me 200 moles of NH3. So basically, I got to know the number of moles of NH3 which are getting formed as per this reaction. It is equal to 200. But am I supposed to calculate the moles of NH3 formed? No way. I'm supposed to calculate the mass of NH3 formed. So mass of NH3 formed will be equal to moles of NH3 formed multiplied by molar mass of NH3, that's 17. So the value comes out to be 3400 grams. So these many grams of NH3 have got formed at the end of the reaction, right? So the correct option is going to be option C. I'm sure it's clear to everyone, right? Okay, let me know in the chat box if it's clear to every single guy. Yeah? Purab is saying said number of moles should be 2. I didn't get it yet. Simple. 1 mole gives 2 moles, right? So 100 moles should give 200 moles. As simple as that. Chinmay, most of the times maths level is definitely going to be tougher than that than that of your chemistry and physics, okay? Right? Nihal, you have to solve more and more mock tests. By solving more and more mock tests, you'll be, getting used to the exam culture, right? Which is really important for the exam. Yeah? Just solve more and more mock tests now. No, Clay, no, nothing like that. No. Perfect. All right, the question, we have got one more asked in JEE Mains 2020 2nd September attempt, right? Let me know in the chat box, what do you think about this question? Well, we are given with 4 curves, and which of the following graphs is not correct for the ideal gas, right? Which of the following is not correct for the ideal gas? And the curves are given between density and temperature, D versus 1 by T, and D versus P. What do you think about this? What do you think about this? Let me know fast. Which of the curve is not correct? Be careful with the terms. It's saying not correct. He's not saying which of the following is correct. Well, let me know fast. People, I hope you remember there is one equation which is the density form of ideal gas equation, which is Pm is equal to dRT. Pm is equal to dRT, right? Or I can say D is equal to Pm divided by R multiplied by 1 by T. I can write it like this as well, right? D is equal to Pm divided by RT, I can say, correct? Now we will understand properly what I'm going to do. See guys, I need to plot a curve between density versus temperature. Density and temperature both are inversely proportional to each other. Whenever I need to plot a curve between 2 variables which will be inversely proportional to each other, the nature of the curve is rectangular hyperbola. So this one is correct one. This one is correct one. I'm not supposed to check the correct one. I'm supposed to check the incorrect one. So D versus T will be absolutely your rectangular hyperbola. The reason is because whenever you need to plot a curve between 2 variables which are inversely proportional to each other, the nature of the curve is going to be rectangular hyperbola, and the first one is rectangular hyperbola, right? Okay, so check the second one, density versus temperature. Since I told you your density versus temperature is going to be hyperbola like this, okay, it cannot be a straight line. Now D versus 1 by T. Can I say this density is directly proportional to 1 by T? Or say this density you're plotting along y-axis and 1 by T you're plotting along x-axis. Density you're plotting along y-axis, 1 by T you're plotting along x-axis, though this whole term becomes m, y is equal to mx means straight line passing through origin. So this is absolutely correct curve, right? Now what about density versus pressure? Density versus pressure. Again, both are what? Directly proportional, y is equal to mx form, so straight line. So this one is also correct. So which one is the only incorrect option among the all? It is going to be your option number 2nd, which is incorrect, and your correct answer is going to be option 2 over here in this case, yeah? I'm sure it's clear to everyone again, right? Let's move on to one more question. The question was asked in your mains 2021. This year, mains 2021, 25th Feb, right? A very simple and the basic question. The spin-only magnetic moment of a divalent ion in the aqueous solution, atomic number is 29. Okay, this is the question on your screen. Give it a try and let me know its answer in the chat box. Well, VSG has come up with option A. What about the rest of the people? Hey Hemant, what's up? After so long, I'm seeing you, yeah? Well, a lot of people are saying option A. So let's get to know exactly what the correct option is going to be. Have a look. The spin-only magnetic moment of a divalent ion. Atomic number is 29. Which element has got the atomic number 29? If you remember, it's going to be copper. It's going to be copper, right? Yes, it's going to be copper. Copper has got the atomic number of 29. Well, what is the outermost configuration of copper? It is, if you remember, copper has got that exceptional configuration 3d10 4s1. But he's talking about the divalent ion of this element. Divalent ion means Cu di positive. So what will be the configuration of Cu di positive? Just take the 2 electron out. One will be going out from S and one will be going out from D. So the configuration becomes 3d9. 3d9 4s0. This is the outermost configuration of Cu di positive. Well, if you exactly want to make the 3d9 configuration 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many unpaired electrons are there in Cu di positive? There is only one unpaired electron. And people, I hope you remember how to calculate the spin magnetic moment. Spin magnetic moment is simply given by the formula under root of n into n plus 2 Bohr magnetrons, right? Well, n is the number of unpaired electrons. Unpaired electron is 1. So root of 1 into 1 plus 1, which comes out to be what? Sorry, root of 1 into 1 plus 2, which comes out to be root 3, and root 3 is equal to 1.7 something, right? 1.7 Bohr magnetrons. So this is the spin magnetic moment, and there is only one option which says 1.73. So 1.73 is going to be your correct answer among all, yeah? That's wonderful. Yes, a very simple and the basic question was asked in your mains 2021 25th Feb attempt, okay? I'm sure it's clear to everyone. Perfect, guys. Let's move on then to the next question. What the question says, the question has been asked in mains 2020 8th Jan. Okay, so let's see what the question says. At constant volume, 4 moles of an ideal gas heated from 300 Kelvin to 500 Kelvin changes its internal energy by 5000 joules. The molar heat capacity at constant volume. A very, very simple and basic question. We are supposed to calculate molar heat capacity at constant volume, which is represented by CV. We are basically supposed to calculate the value of CV, right? Molar heat capacity at constant volume, correct? Well, people, it's given that the internal energy changes by 500 joules. So the value of delta U is given to me as 5000 joules, right? What else is given? The initial temperature of the gas is also given to me, which I'm representing by T1. T1 is given to me as 300 Kelvin. The final temperature of the gas is also given to me as 500 Kelvin. What do I need to calculate? I need to calculate the value of CV, right? And since it is the ideal gas, and for an ideal gas, we know delta U is equal to NCV delta T, which is T2 minus T1. So I can clearly say your delta U, which is 5000 joules, I believe, right? Is it 5000 joules? Yeah, 5000 joules. N, number of moles of ideal gas. We have got some 4 moles of ideal gas, right? CV value, we are supposed to calculate T2 minus T1. T2 is 500, T1 is 300, so 500 minus 300 comes out to be 200. So the CV value over here comes out to be 5000 divided by 4 2s are 800, correct? Like this. Okay, so which should be the correct option? 0000 cancel, so 8186, so it's going to be 6 point what? 86 are 48, 6.25 joules per Kelvin per mole, right? So 6.25 is there one option, which is option number 2. So option number 2 is going to be the correct one among all. A very, very simple and the basic question, right? In your mains 2020 8th Jan attempt, right? Hello Saqib, what's up? How are you? Yes, Akash, absolutely, you can join. Utkarsh, I'm an engineering graduate, right? I'm basically a civil engineer. Okay, teaching you guys the chemistry. Perfect, let's move on. Let's move on to one more question. See guys, what kind of simple question was asked in your mains 2019 from the chapter equilibrium, right? A very simple and the basic question, right? See, I was given two reactions. This was reaction number 1, this was reaction number 2. We were given with the equilibrium constants of the two reactions and we were supposed to calculate equilibrium constant of this reaction. Okay, how to solve this question? How to solve this question? Understand? First of all, let me tell you, for this reaction, I'm supposed to calculate the equilibrium constant, okay? So what I'll be doing right here is, I'll be trying to make this reaction from the given two reactions. I'm going to make this reaction from the given two reactions. Now the point is, how do I make this reaction, okay? So basically I have to make it 2 times SO. I have to make a reaction in which on reactant side you should get something as 2 times SO. 2 times, wait, it should not be 2 times SO. It should be 2 times SO2. It is not 2 times SO, okay? It's 2 times SO2. 2 to the 4 to the 6. Yeah, it's 2 times SO2. So on the left side, I should get some 2 times SO2. For that, I need to multiply the first equation by 2. If I'll be multiplying the first equation by 2, that 2 goes to the power of equilibrium constant, right? That 2 goes to the power of equilibrium constant. And after that, I'll be reversing this first reaction. If I reverse the first reaction, it becomes 2 times SO2 in equilibrium with 2 times S plus 2 times O2. Now when you reverse the reaction at equilibrium, its equilibrium constant gets inversed. So equilibrium constant of this reaction is going to be 1 divided by 10 raised power 52 multiplied by 2 comes out to be 104, right? Okay. Now people, you have got the second reaction, which I'm writing as such, 2 times S plus 3 times O2 in equilibrium with 2 times SO3. Its K value, its equilibrium constant is given to me as 129. Okay. If I add these two reactions, what do I get? If I add these two reactions, 2 times sulfur cancel, 3 times O2, but over here 2 times O2. So 2 times O2 will get cancelled out with 2 times O2. So I'll be left with 1 O2 on the left hand side. And already we have got some 2 times SO2 in equilibrium with what? 2 times SO3 I'm getting over here, right? Okay. So people, since I've added these two reactions, and you all must be knowing when we try to add the two reactions, their equilibrium constants are multiplied. So what is going to be the equilibrium constant of this reaction? It's going to be this multiplied by this. So 10 raised power 129 multiplied by 1 divided by 10 raised power 104. So the value comes out to be simply 10 raised power 25. So 10 raised power 25 is the equilibrium constant of this reaction which I was supposed to calculate. See, I got the same reaction for which I was supposed to calculate the equilibrium constant. So for this reaction, equilibrium constant value comes out to be 10 raised power 25. Yeah. Okay. Right. As simple as that. Yeah. User VIT is known for CS only, computer science only. Perfect. So it's going to be option number 1. Let me know in the chat box if it is clear to everyone. Let me know fast. Akshat, you can do it. Trust me on that. You can do it. Just focus on your NCRT now. Yeah? Perfect, guys. Let's move on. Let's move on to one more question. Then let's try to solve a few more. Okay, we have got one more question. The correct order of acidic character of the following compound. The question was asked in mains 2021, 25th attempt. That means this year only this was asked, right? This year only this question was asked. I need to check the acidic strength, yeah? Okay. First of all, what you'll be doing over here is, see, just select your reference. Select your reference. See, you have got COH, 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 this is OH, correct? Okay, I selected the site from where hydrogen is going to leave as H positive. I selected the site from where hydrogen is going to leave as H positive. Okay, when hydrogen from here leaves as H positive, there will be negative charge on this oxygen. When hydrogen leaves from this site, there will be negative charge on this oxygen. When hydrogen leaves from this site, negative charge over here. When hydrogen leaves as H positive, there will be negative charge over here, right? Now simply compare the stability of these negative charges. Wherever negative charge is going to be the stable, there only the hydrogen which has left as H positive, that is going to be maximum acidic, right? Okay, or simply without doing all this, you can do just one thing. You can remember one thing. Your acidic strength that is basically directly proportional to minus effect. Acidic strength is directly proportional to minus effects. Okay, and remember minus M dominates over minus H, and minus H dominates over minus I, right? Remember this, or no need to write minus H over here. You can simply write minus M, it dominates over minus I, right? Well, people, you need to check the effect of the groups over here. This NO2, it is going to show minus M effect over here. This CH3, it is going to show plus H effect over here, plus hyperconjugation, yeah? Okay, so first of all, there is minus effect only in one molecule, that is the second one. So second one is going to be maximum acidic, second one is going to be maximum acidic. So there is only one option which shows second one is maximum acidic, so it's going to be option number 1 only, right? No need to check the rest. No need to check the rest. You need to be smart at the same time as well, yeah? Okay? Right? Right? And which one is going to be? Is there any option which says second is the maximum acidic? Is there any option which says second is the maximum acidic? No. There is not any option which says second is the maximum acidic. So it's going to be the second, which is going to be the maximum acidic, right? Yashwant, you can go for more than 200, right? 200 plus is a good score in mains. Okay, let's move on to one more then. Well, people, the question was asked in your mains 2020 6th September session, yeah? And I'm sure you can kill this one. Arrange the following solutions in the decreasing order of POH. Be careful, decreasing order of POH. First of all, I've got HCl. In case of this HCl, the concentration of this HCl is given to me as 0.01. That means in case of HCl, the concentration of H positive. Since HCl is a strong acid, it would have got completely converted into H positive and Cl negative. So concentration of H positive basically is 10 raised per minus 2 mole, right? 0.01 means 10 raised per minus 2. So if I calculate the pH is simply going to be what? pH is going to be minus log of this, minus log of 10 raised per minus 2 comes out to be 2. Since pH is 2, so POH is going to be equal to 14 minus 2, that is 12. So in the first case, the POH is 12. In the first case, the POH is 12. The second case is 0.01 molar NaOH. Since NaOH is a strong base, it would have got completely converted into Na positive and OH negative. So in the second case, your OH negative concentration is basically 0.01, which is 10 raised per minus 2 molar. If you have OH negative concentration, you can simply write the POH, which is minus log of this term. So POH is 2. Right? Since OH you got, minus log of OH is basically 2, right? Yes, as simple as that. Now we will the third case. You have got a salt over here, CH3COONA, right? You have got a salt. Let me write it somewhere over here, CH3COONA. In this CH3CONA, you have got two parts, CH3CO negative and Na positive. This CH3CO negative in the salt would have come from CH3COH, and this Na positive would have come from NaOH. So we know this is a weak acid and this is a strong base. Weak acid, strong base. This is a salt of weak acid and strong base. So its pH is going to be greater than 7, right? Since it is a salt of weak acid and strong base, so its pH is going to be greater than 7. If its pH is greater than 7, that means its POH is going to be less than 7. Its POH is going to be less than 7. Okay? And at the end, we have got a salt of a strong acid and strong base. So its pH as well as POH, both the ones are going to be 7, right? Okay? Now you can arrange them on the basis of what? Arrange the following solutions in the decreasing order of POH, which has got the maximum POH. The first one has got the maximum POH. That means your HCl has got the maximum POH, right? In the decreasing order, he's saying, I guess, yeah? He's asking about the decreasing order. So maximum POH is shown by the first one. So A is going to show maximum POH. After that, what comes? After that, POH 7. POH 7 is for D, right? After A, D will come. After D, this POH less than 7 will come. That means C, right? And then what is going to come at the end? You have got POH2. POH2 is for this NaOH, which is B. So this is the decreasing order of POH. Is there any option resembling with this? A, D, C, B, right? A, D, C, B. So second option is the one which is correct among all, yeah? Right? Chess lover, I've already started atomic structure in NEET lead channel. You can follow the lectures as well. I'm teaching the same level. I'm teaching mains level also only there in the NEET lead channel. Surely, Preksha, I'll be doing that. I'll be doing that, no issues. So the correct option is going to be option number 2, which I guess clear. The total number of lone pairs of electron in I3 negative. A very simple question. See, this question is asked in your mains 2018. I3 negative. People, you should know the I3 negative structure. First of all, let me tell you, in I3 negative, the hybridization is sp3d, if you remember, yeah? This question was asked this year also. What is the hybridization? What is the hybridization involved in I3 negative molecule? It's going to be sp3d, okay? In case of in case of this I3 negative, the shape is basically linear. Shape of this molecule is linear. Shape of this molecule is linear. And the geometry of this molecule is trigonal bipyramidal. Trigonal bipyramidal, okay? Let me show you exactly how this molecule looks like. This is iodine. This is one lone pair. This is one more lone pair of the same iodine. This is one more lone pair of the same iodine. And all these 3 lone pairs, they are present in the same plane. One iodine is above it and one iodine is below it, okay? And people, on this iodine, you have got 3 more lone pairs, if you remember. On this iodine, you have got some 3 more lone pairs. So how many total lone pairs are there in I3 negative? 3, 3, 3, 6, 6 and 3, 9. So total there are 9 lone pairs in this I3 negative. So if it was asked like this, how many lone pairs are present in the central atom of I3 negative? The answer at that time should have been 3, okay? But right here, he's not talking about the total number of lone pairs in the central atom. No, he's talking about the total lone pairs in this I3 negative molecule. Suresh, this is the English channel, bro. This is the English channel. Yeah? Perfecto. Let's move on to one more then. Okay, this question was asked in your mains 2026 September. Mains 2026 September attempt. A set of solutions is prepared using 180 grams of water as a solvent and 10 grams of different non-volatile solute A, B, C. So basically I've got 3 solutions. In the first solution, you have got the solute as A. In the second solution, you have got solute as B. In the third solution, you have got solute as C. The relative lowering of vapor pressure in presence of these solutes are in the order of. We are given with the molar mass of A, B and C as well. Well people, if you remember, colligative property is inversely proportional to molar mass of solute. This is the molar mass of solute. Yes. So wherever molar mass of solute will be least, there only colligative property will be maximum. Be it relative lowering in vapor pressure, be it your depression and freezing point, be it your elevation and boiling point, be it your osmotic pressure. Wherever molar mass is minimum, there only a relative lowering of vapor pressure is maximum. So molar mass is minimum in the first case. So in the first case, you'll be having maximum value of relative lowering in vapor pressure, right? So A is going to show maximum value of relative lowering, right? Followed by your B and then followed by your C. So ABC is going to be the order, as simple as that. ABC is going to be the order, right? Okay. Yes, I'm sure it's clear to everyone now. Yeah? Well guys, tomorrow on there is a channel called as Catalysis by Vedantu. Tomorrow at 8 p.m. I'll be doing some 100 questions on general organic chemistry, which is going to absolutely revise your entire GOC, okay? You can join in the tomorrow session at 8 p.m. on Catalysis channel, right? Okay, Catalysis by Vedantu channel, I'll be joining in tomorrow at 8 p.m. You can also join in. Tomorrow we'll be solving some top 100 questions from your general organic chemistry, yeah? Okay, perfecto. Let's move on to one more then. Okay, among the following, the aromatic compound is. The question was asked in JEE Mains 2019 11th Jan. Okay, so we will how many? Not how many. Arrange. I need to check which one is the aromatic among the following. Right. For the molecule to be aromatic, I hope you remember the conditions. First, the molecule should be cyclic, and all the molecules are cyclic. No issues at all. Correct. Every atom in the cyclic ring should be sp2 hybridized. Okay. See, every atom over here is sp2. Right here, again, every atom is sp2. Right here, every carbon is sp2. But over here, this carbon is sp3. So this cannot be aromatic. First, gone. Yeah. Now, there should be complete cyclic conjugation. There should be complete, you can say, cyclic conjugation involved in the molecule. Right. Over here, in the first one, do we have complete cyclic conjugation? Absolutely. You have got pi sigma, right? This is positive charge in the pure p orbital. So you have got the conjugation right here as pi sigma and positive conjugation. Yes. In the second one, do we have the conjugation? Yes. This pi bond is in conjugation with this one. This pi bond is in conjugation, right? So you have got complete cyclic conjugation involved. Again, this negative charge is in conjugation with this one. This negative charge is in conjugation with this one, right? So again, you have got complete cyclic conjugation. In all these three, you have got complete cyclic conjugation. Now, you are going to check the Huckel's rule. As per Huckel's rule, the aromatic molecule will have 4n plus 2 pi electrons involved in the resonance, right? Over here, you have got 1 plus 1, only 2 pi electrons involved in the resonance, involved in the cyclic conjugation. Over here, you have got 2 to 4. You have got 4 pi electrons involved in the complete cyclic conjugation. Over here, you have got 2, 4, 6, and this negative charge, which I am taking as the lone pair. So 2, 4, 6, 8. You have got 8 pi electrons involved in the cyclic conjugation, right? So for the molecule to be aromatic, there should be either, put the value of n as 0, there should be either 2 pi electrons involved in complete cyclic conjugation, or should be 6 pi electrons, or should be 10 pi electrons, right? If n value is 0, it's going to be 2. If n value is 1, it's going to be 6. If n value is 2, it's going to be 10. So now check. Since the first one has got 2 pi electrons involved in the complete cyclic conjugation, so it's going to be aromatic. This has got 4 pi. No way, it's not going to be aromatic. This has got 8 pi. 2, 6, 10. No, it's not going to be aromatic, right? So first one is going to be the one which is going to be aromatic among all, right? Shubham, I'm really sorry, bro. This is the English channel. Yeah, I'm not supposed to talk in Hindi. This channel is particularly for the ones. This channel is particularly for the ones who cannot understand Hindi. Yeah. Okay. Perfecto, guys. Wonderful. The third one is anti-aromatic. It's not non-aromatic. This one is non-aromatic because you have got sp3 hybridized carbon over here. Yeah? Okay. Let's move on. See, as I told you, this is anti-aromatic. This one is non-aromatic, right? Okay. The first one is the only aromatic one. Okay. One more question from JEE Mains 2019, 8th April, right? You can give it a try. Let me know the answer. The strong oxidizing agent. Oxidizing agent is the one which oxidizes others but itself undergoes reduction. Now I need to check which one among the following undergoes reduction easily. That one among the following will undergo reduction easily, which will have strong reduction potential, which would have very high SRP, very high standard reduction potential, right? See, over here, this is the standard reduction potential value which is given. This is again your SRP value given. This is again your SRP. This is again your SRP. Now check it out. Which one is having maximum SRP? Maximum standard reduction potential is shown by the second one. If the second one shows the maximum standard reduction potential, so second one has got the most tendency to get reduced, and that one which has got most tendency to get reduced, it acts as the better oxidizing agent. So which one is the better oxidizing agent among the all? So this S2A dinegative is the better oxidizing agent among the all. As simple as that, right? Yes, exactly. Majority of you are right. Wonderful, guys. Gopi, that's what I'm telling. Tomorrow at 8 p.m. on Catalysis channel, I'll be starting the general organic chemistry, not from the basics exactly. I'll be coming up with some 50 to 100 questions, right? And by solving those questions, your entire GOC will be getting revised through questions, yeah? So do attend that session tomorrow at 8 p.m. on Catalysis channel. Okay, the enolic form of acetone contains, okay? This question was also asked in your JEE, I don't remember the year exactly. The enolic form of acetone, okay? What is the keto form of acetone? Just a second. What is the keto form of acetone? This is CH3, this is C, double bond O, this is CH3. This is the keto form of acetone, right? Okay. Now, if you want to draw its enol form, right? Enol is its tautomer, right? So first of all, what is going to be its enol form? In order to draw the enol form, you are simply going to take this double bond over here. So just take the H positive from here and attach that H positive with this oxygen. So your enol is going to be CH3, this is C, this is OH, right? This is OH, and over here you get the double bond. This will be CH2, right? Now this is something which I call as enol form of the above keto one, right? Both these forms will be absolutely in equilibrium with each other. Yeah, we know it. Now basically we are supposed to check the total sigma bonds and total pi bonds in the molecule in the enol form. In this enol form, you have got only one pi bond. So first one says 1 pi bond, it can be the answer. Second one says 2 pi bonds, it cannot be the answer. Third one says 1 pi bond, it can be the answer. Fourth one says 2 pi bonds, it cannot be the answer. So our answer is either going to be 1 or the third one. Now calculate the sigma bonds, right? This is 1 sigma, 2 sigma, right? Let me make it exactly. See, over here this carbon is attached with 2 hydrogens, so 2 sigma, 3, 4, 5, 6, 6 and 3, 9. So total there are 9 sigma. 9 sigma, so option 1 is going to be the one. And there will be 2 lone pairs, and these 2 lone pairs will be on this oxygen right here. Yeah? Exactly, it's going to be option number 1. Correct? I'm sure it's clear to everyone again. Wonderful, guys. Great job done. Yeah? Okay, one more question. The volume in milliliters of 0.02 molar K2Cr2O7 solution required to react with 0.288 grams of ferrous oxalate in acidic medium will be. Okay? See, guys, a very simple question. First of all, I would like to share one thing with you. KMnO4 and K2Cr2O7 both act as a strong oxidizing agent, and in acidic medium they have got the tendency to convert Fe di positive into Fe tri positive, and both the two in acidic medium they convert your oxalate ion into carbon dioxide as well. Yeah. So first of all, what is going to happen over here? See, I'm going to make K2Cr2O7. I'm going to make K2Cr2O7 to react with the, is it ferrous oxalate or ferric oxalate? It is ferrous oxalate, FeC2O4, and the reaction takes place in acidic medium, right? So K2Cr2O7, it converts Fe di positive into Fe tri positive, if you remember, right? And at the same time, it converts oxalate ion C2O4 di negative into carbon dioxide. You know this as well. And itself, it gets converted into Cr tri positive. And with this, you'll be writing some water as well. Okay? Only thing which you need to remember. Your K2Cr2O7 or KMnO4, it converts Fe di positive to Fe tri positive and oxalate ion into carbon dioxide, right? Now have a look. First thing, let's call this as 1. Let's call this as 2. Okay? What is the oxidation state of chromium right here? It's +6. What is the oxidation state of chromium right here? It's +3. +6 to +3. What is the change in oxidation state of chromium? +6 to +3. 3 is the change in oxidation state. But that 3 is the change in the oxidation state for 1 atom of chromium, but I have 2 atoms. For 1 atom of chromium, the change is 3. For 2 atoms, the change is going to be 6. So N factor of K2Cr2O7 in this reaction is going to be 6. Yeah? Now what about the N factor of this ferrous oxalate over here? See, guys. Fe di positive gets converted into Fe tri positive. So it loses 1 electron. Fe di positive, it is losing 1 electron from Fe di positive to Fe tri positive. See, carbon from +3 to +4. +3 to +4. Again, 1 atom of carbon loses 1 electron, but I have 2 atoms of carbon. So 2 atoms of carbon are going to lose 2 electrons. So in total, how many electrons are being lost by 1 mole of this ferrous oxalate? It's going to be 2 + 1, 3. So N factor of this ferrous oxalate is going to be 3. So I got the N factor of both, right? Now what I'll be doing, as per equivalent concept, you can clearly see milli-equivalence of 1 reacted should be equal to milli-equivalence of 2 reacted. Yeah, milli-equivalence of 1 reacted will be equal to normality of 1 multiplied by volume of 1 in milliliters. Okay, which is going to be equal to milli-equivalence of 2, milli-equivalence of ferrous oxalate. Since I need to calculate mass of ferrous oxalate, I guess. Yeah. No. Okay, I'm given with mass of ferrous oxalate. So milli-equivalence of ferrous oxalate, I'll be writing mass of ferrous oxalate in grams divided by molar mass of ferrous oxalate, right? Multiplied by, not molar mass, sorry. Given mass of ferrous oxalate divided by equivalent mass of ferrous oxalate multiplied with 1000, right? This is how I'll be writing the milli-equivalence of second, that means milli-equivalence of this ferrous oxalate, okay? Now, normality of first, normality of K2Cr2O7, that's going to be molarity of K2Cr2O7, which is 0.02, multiplied by N factor of K2Cr2O7, that is 6, multiplied by V1, which I'm supposed to calculate, is equal to mass of ferrous oxalate, it's given to me as 0.288. Since you can calculate the equivalent mass of ferrous oxalate as well, equivalent mass of ferrous oxalate is going to be equal to molar mass of ferrous oxalate divided by N factor of ferrous oxalate, and N factor of ferrous oxalate is 3. What is the molar mass of ferrous oxalate? You can calculate the molar mass of ferrous oxalate. Iron has got 56, right? 56 plus 24, I'm writing 56, then I'm writing 24, then I'm writing 64. So it's going to be 4, 4, 8, 8, 6, 14, right? 5, 1, 6, 6, 2, 8, 8, 6, 14, 144. 144 is the molar mass of ferrous oxalate. So it's going to be 144 divided by 3, which is the equivalent mass of ferrous oxalate multiplied with 1000. So over here, you got one equation, and in this one equation, you have got only one variable, that is V1, where V1 is the volume of K2Cr2O7, which I was supposed to calculate, right? So V1 value from this equation you'll be calculating, and let me give you the exact value of V1. V1 value comes out to be what? 50 ml, right? So basically 50 ml of 0.02 molar K2Cr2O7 solution is required to react with 0.2 to 8 grams of ferrous oxalate in acidic medium, right? The question was asked in mains 2020, basic equivalent concept question, yeah? Okay. Now people, moving on to one more question. The question was asked in your mains 2020 7th Jan, right? Mains 2020 7th Jan. For the reaction is given to me as A liquid gives 2 times B gas, delta U is given to me, delta S is given to me, temperature is given to me. We need to calculate delta G. Okay, we need to calculate delta G. First of all, delta G is nothing. Delta G is equal to delta H minus T delta S, right? So delta G will be equal to, is the value of delta H given? No, the value of delta H is not given. So I need to calculate delta H first. Minus T. What is the T given? Temperature. It's 300. What is the delta S value that's given to me? Delta S should be given to me, right? How much is delta S? Okay, delta S is 20 calories per gallon, right? In order to calculate delta G, I need to get the value of delta H first. Now, how do I calculate delta H, right? How do I calculate delta H? Delta H is simply going to be equal to delta U, right? If you remember, people, do you remember the relation between delta H and delta U? Delta H is equal delta U plus delta Ng RT. I hope you remember this, right? Now delta H is going to be equal to, delta U should be given to me. Is delta U given, right? 2.1 kilocalories. So 2.1 multiplied by 10 raised power 3 calories. Okay, plus what is the value of delta Ng for this reaction? Delta Ng means number of moles of gaseous products minus number of moles of gaseous reactant. So there is no gaseous reactant. Number of moles of gaseous products, that is 2. 2 minus 0, that is 2. So delta Ng is 2, right? Okay. R I'll be using in calories, that is 2, and temperature is given to me as 300, correct? And this value again is in calories, right? So you will be calculating the value of delta H from here. Once you get the value of delta H, you'll be putting that delta H into this equation, and you'll be getting delta G from here, and then delta G, that delta G I was supposed to calculate basically, right? Okay. As simple as that, right? Let me give the exact answer of this. See, first of all, I've used delta H is equal to delta U plus delta H RT. So you got some delta H as 3,300 calories. So put that delta H into this equation, you get the answer as 2.7 kilocalories, right? Okay. Basically, you got the answer as 2,700 calories, which comes out to be 2.7 kilocalories. I was supposed to calculate the value of X, yeah? X comes out to be 2.7. X is the 2.7 is the answer of this question, right? Well, people, this is one more question from the chemical kinetics. The question was asked in mains 2021. Can you give it a try and let me know its answer fast? Chandrasekharan, you need to speed up, bro. Well, people, a very simple question this is. Very simple question. A reaction has the half-life of 1 minute. The time... wait. Just modify the question. You write it as a first-order reaction. A first-order reaction has a half-life of 1 minute. So T half for the first order reaction is given to me as 1 minute, right? The time required for 99.9%. Time required for 99.9% completion of the reaction is X minutes. What I need to calculate? Determine X, right? A very simple question. I'm simply going to tell you one direct result by means of which you can solve this question, or let me tell you some results. Remember, time taken to complete 75% of the first order reaction is 2 times the time taken to complete 50% of it. This is only valid for first order reaction. Similarly, remember one more thing. Time taken to complete 87.5% of the first order reaction is equal to 3 times the half-life. It is also valid for a first order reaction. And at the same time, remember, time taken to complete 99% of the first order reaction is equal to 10 times the half-life of the reaction. This is again valid for a first order reaction, correct? I'm going to use this result over here. Yeah, I'm going to use this result. Well, time taken to complete 99.9% of the reaction is 10 multiplied by T half. TF is given to me as 1 minute, so 1 multiplied by 10 comes out to be 10 minutes. So simple, time taken to complete 99.9% of the reaction is going to be 10 minutes. So 10 minutes is going to be the answer of this question. Or you can use the direct result, you can use the general procedure, you'll be again getting the value as 10 minutes, right? I'm sure you'd have enjoyed this session, and with this I'll take a leave. But before taking the leave, let me tell you, for the ones who have not enrolled in the JEE 2021 crash course yet, please do get enrolled in it as soon as possible, because this is the best and the last option for you. Okay, people, we are going to cover your whole syllabus in this crash course on the actual Vedantu platform, right? Okay, in just 120 sessions before your mains examination, before your next mains examination, which is going to happen most probably in next month or whatever, whenever. Before that, we are going to cover your whole syllabus. Apart from that, no need to worry about the test series, no need to worry about the mock test. Everything is included in this crash course, right? There will be some extra sessions with the experts by means of which you can increase your problem solving skills, right? And people, it's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers, right? The next batch is starting on 14th of this month. Do get enrolled in the batch as soon as possible. And how to get enrolled? If you want me to train you personally, do not forget to use this coupon code WSCC. This is my personal coupon code, Wassim says crash course. And if you use this coupon code, you'll be getting some 40% off. And after the 40% off, you're just getting this crash course for 6K. Yeah? Do get enrolled in this. Link is there in the description box of the video. Do click on that link, use the coupon code WSCC and get enrolled to the crash course batch and shoot the bullseye with us. Yeah? There is one more link in the description box, that's for the Telegram. Do click on the link, get added to the Telegram group and stay updated about the classes. And at the end, the ones who have not liked the video yet, please and please do like the video, share the video with your friends, and do not forget to subscribe to the channel, yeah? Okay, Basit, the next session for class 11th atomic structure will be on Tuesday. Yes. So people, it was nice meeting you. The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking over here live on this JEE Enthuse channel. And people, do not forget to catch me up tomorrow at 8 p.m. on the channel Catalysis by Vedantu. Tomorrow I'm going to do some super 100 questions from the general organic chemistry. Do meet me tomorrow at 8 p.m. sharp on Catalysis. Yeah. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye. Thank you, Manisha. Thank you, Kirtana. Absolutely, I'll be coming. Thank you, Ayushi. Thank you, Clay. Welcome. Bye, 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 Basit. Bye. Take care, guys.